Wiki pages for the general compounding formula. I want to show you one more time how to write these formulas out in your Wiki pages so that you can understand what I'm looking for when I grade these. First thing is I want you to have a description, and if you can get it from my video, what I've said about the formula, that's a really good place to start because that is going to help you distinguish between all the formulas that we do in this chapter and which one you need. So remember, the general compounding formula is different from the simple interest formula in that when you put a lump sum of money into an account for savings, interest gets calculated n times a year instead of just one time at the end, and it's calculated on the principal and any interest that got calculated before the time of the current calculation. So if I have interest compounded annually, then I'm going to calculate interest at the end of the first year, add it into my account, calculate interest at the end of the second year on the interest and on the principal, put that into the account. At the end of the third year, I'm looking at the principal, interest from first year, interest from second year, and I'm putting all that together and calculating interest on that. Fortunately, we don't have to do it step by step like that. We have a formula that will take care of all of that all together, and that formula is FV equals PV times the quantity 1 plus R over N raised to the NT power. Make sure you show your exponents higher than the regular numbers and fractions in your problem. Then remember, I want to see every variable with a short description. So FV be future value, PV present value, or starting, R is the rate as a decimal, T is still time in years, and then N is the new thing, and that's the number of compoundings per year. And for this formula, we probably should put N values just so that we can remember. If we have an N of 1, that means annually. N of 2 would be semi-annually. 3 we don't have, of 4 we have, and that's quarterly. And then we don't have anything else until 12, which would be monthly. And then after monthly, we have 52, which is weekly, and 365, which is daily. So those are our N values. So all of that is really good for us to put there for the formula because that's all things that deal directly with filling in the formula. Now the FV, I'm noticing right up above it says A equals. The FV and the A are the same thing. So you could have an A here or FV. Sometimes it's future value, sometimes it's just ending amount. Words, remember, are the words that are going to help me identify for a particular problem that this compounding formula is the one that I want to use. And so I'm going to look for words like compounded, and then any of the annually, or I could have monthly or daily. And in fact, any of those divisions of time that I'm showing up here could be shown in my formula, in my example that I'm trying to work out. So any of those, but I just wrote the 3 that are the most common. The other thing is this is solved for the future value, so we're going to find out how much money will you have after investing some present value. So we're finding out how much is in the account after a certain amount of time and a certain amount of money dropped in a big chunk into the savings account. Steps or notes is really there for you. So if you want to list out, you can put the order of operations, anything that you need to put in there to help you round to the nearest cent at very end. If you want to write down some calculator buttons that you need to use, that's your space. You write what's helpful for you. I don't grade that at all.